Hello and welcome to another video in the series Server-Side Swift using Vapor. So in the last few videos I demonstrated how we can implement a parent-child relationship in our Vapor Swift models, and in this video I'm going to show you how we can implement a many-to-many relationship, which is also known as a sibling relationship. So a many-to-many relationship describes a relationship that links two models to each other, and these are also known as sibling relationships. So unlike parent-child relationship, there is no constraint between the models in the sibling relationships. So what that means is that each element of either of the models can have a relationship with one or more elements from the other model. And how we are going to implement this in our periodic table app is by creating a new model which will list all the alloys that can be created using the elements of our periodic table. So here, as you can see in this example, if we are making the solder alloy, it uses copper, silver and tin. And similarly, the members of our alloy category can use multiple periodic table elements to create them, and similarly multiple periodic table elements can be used to make different alloys. So that is how we're going to define this siblings relationship. So let's implement this in our periodic table application. So let's open up terminal, because we need to create some new files, and I'll just change the directory to the Vapor folder and to our periodic table app. And here again I'll use the touch command to create a new file in the models folder, and I'll call this alloys.swift. And similarly I'll create a new file in the controllers folder, which will be called alloys_controller.swift. Great, now we can just regenerate our Xcode project. So let's go to the alloys.swift file that we just created, and here we can define a class for our alloys object. So I'll start with importing Vapor, and we are using the PostgreSQL database. I'll just import Fluent PostgreSQL, and then we can just define our class, and inside the class I'll define an optional ID, which is an integer, and a name of the alloy, which is a string value. Now this ID property is optional because it will only have the value when we set it. And along with that I'll also create an initializer function, and we'll make our alloy model conform to the Fluent's PostgreSQL content migration and parameters by adding the extensions. And similarly, like we did in the periodic table.swift file, we'll just define the database in the PostgreSQL models extension. Great, so our alloy object is ready. Finally, just go to the configure.swift file, and at the end of the file we'll add the alloy model to the migration list. Now let's open up the alloys controller Swift file that we just created, and we can define our controller here. And we'll add the boot function. So in one of my previous videos I had already explained how the controllers work in a Vapor application, so make sure you check that out before this video. So similar to what we did in the elements controller and the users controller Swift file, we'll create a routes group here, and I'll call it alloys root. And here we can just define the endpoints for the alloys APIs, and we'll make a few post and get requests. So now let's create the get all and create handler that we mentioned here. And finally, we'll create the get handler. So I hope by now all these functions are pretty clear to you, because we have been using them for a while now. And finally, we can go to our routes.swift file, and at the end of this file we can just register the new controller that we just created. So our new model has been set up, and we can go ahead and run this application. And let's make a post request to test out our new APIs. And in the parameter, I'll just add a single value, which is name. So great, our new APIs are working. Let's get back to our project. So in the last video, when we created a parent-child relationship, we added a reference to the user in the elements to create the relationship between the periodic table element and the user. However, we can't model a sibling relationship like this, as it would be too inefficient to query. Now, if we had an array of periodic table element inside of an alloy, to search for all the alloys of an element, you would have to inspect every single alloy. And similarly, if you had an array of alloys inside of a periodic table element, to search for all the periodic table elements in an alloy, you would have to inspect every single element. So we need a separate model to hold on to this relationship. And in Fluent, this is called a pivot. So a pivot is another model type in Fluent that contains the relationship. So let's close this Xcode project, and we'll make a new class using the terminal. So again, I'll use the touch command and make a new file in the models folder. And I'll call this element alloys pivot.swift. And let's regenerate our Xcode project. Now let's open up our new element alloy pivot.swift file. And here we can define the class which will be used to hold the sibling relationship in this app. So for this, we'll require the foundation class. So this new object will conform to the PostgreSQL UUID pivot, so that it contains a universally unique identification to manage each relationship. And inside of this, I'll just define an ID variable, which will be a universally unique ID. And next, we'll just define the IDs for our element and our alloys respectively. So after this, we'll just define the left and right types which are required by any pivot class. And next, we'll just tell Fluent the key path of the two ID properties for each side of the relationship. And now we'll just create an initializer function to initiate the sibling relationship. Great, so our pivot class is ready. And finally, we can just make the migration and modifiable pivot extensions. Great, so now we'll just go to configure.swift file, and we can register the new migrations here. So this will add the new pivot model to the migration context, so that Fluent prepares the table in the database at the next application start. Now this is showing an error which we can fix by creating the database model in our element alloy pivot.swift file. Right, so this is resolved now. So to actually create the relationship between the two models, we need to use the pivot. Fluent provides convenience functions for creating and removing these relationships. So first, let's open up our periodic table.swift file, and we can add a new computed property in the extension that contains the user computed property. So here we're using the Fluent's sibling function to retrieve all the alloys, and Fluent will handle everything else. Now we'll open up our elements controller.swift file, and here we'll define a new method to set up the relationship between the periodic table elements and the alloys. So in this function, we are defining a new route, which is add alloys handler, and this will return a HTTP status request. And we're using the flatmap2 method to extract both the periodic table element and the alloy object here. And we're using the attach on method to set up the relationship between the alloy and the element. And finally, we're transforming the result into a 201 created response. Now we'll just register this new handler at the bottom of our boot function. So this route is a post request to the API/element/ the periodic table parameter, which would be the ID of the periodic table, /alloy, and /the alloy parameter, which would be the ID of the alloy. So let's go ahead and run this application, and we can test out this new post request that we have made. So let's test out our new API in the Postman app. So before you actually do that, make sure that you create a new user and a new element and a new alloy, because every time we restart our application, our database will reset. So that's why all of these values should be present to test out this API. Okay, so for this, I'll just add the endpoints of the new API. I'll use the element ID, which is 1, and alloys after that, and the ID of the alloy, which is also 1. And I'll set the request to post. So as you can see, we are getting the 201 created response. So that means our new API is working. So that's it for this video. In the next video, I'll show you how we can query this relationship. Thank you so much for watching, and make sure you subscribe so that you can be notified when the next video drops. Thank you.